All right, let's do this perpendicular bisector problem, which honors kids is like number 2 on your chapter 5 test review sheet. Perpendicular bisectors, they make right angles, hence the word perpendicular, and they cut line segments in half. That's what a bisector does. So I have drawn a line segment here, AB. You have the little box for the perpendicular part. You have the two little tick marks, one on each side, that tells you, let's call this point in the middle D. Tells you from A to D and B to D are exactly the same. And then this line that goes from C to D through those, that's your perpendicular bisector. That's the thing that's doing the cutting in half and making the right angle. So this is our perpendicular bisector. And one of the characteristics of a perpendicular bisector is that any point on this perpendicular bisector will be just as far from A as it is from B. So my point C up here is on the perpendicular bisector, so it's just as far from A as it is from B. So let's say you find out that from A to C is y squared plus 4y, and from B to C is 7y plus 18. Since those distances have to be the same, since C is on the perpendicular bisector, you're going to start by setting them equal. So I'm going to do y squared plus 4y, and then equals 7y plus 18. Okay, now y squared means you're probably going to factor. Okay, but you can only factor if this right side is equal to 0. So you need to move everything on this right side over here over to the left so that that right side says equals 0. So I'm going to subtract the 7y from both sides. And then while I'm at it, I'm going to subtract the 18 from both sides. So when we do that subtraction, we're still going to have our y squared. Positive 4 minus 7 is negative 3y. And then since there was no just plain old number, we call that the constant term. To subtract the 18 from, it's just minus 18. And then we have equals 0. And now we can factor. So just like any other time we factor, if there's no number in front of the y squared or the x squared, whatever variable you're using here, you're going to start with a y, in this case, in each parentheses. And as we've said before, we're looking for numbers that are going to multiply to give you this negative 18, and then are going to combine or add to give you that negative 3. So immediately I start thinking 6 and 3. I know they're 3 numbers apart, so when I combine them, I can get some version of a 3 right here. So I'm going to go with 6 and 3. And we've said before in class and in other videos that whatever this symbol in the middle of your equation is, the larger of your two factors, 3 and 6, is going to take that symbol. So I'm going to have y minus 6. And then since I need to multiply and get negative 18, that means this 3 has to have a plus, because the only way you can multiply and get a negative is to multiply a positive and a negative. Now, this doesn't say y equals yet, and it needs to, because we haven't officially solved for y until it does. So I'm going to say, since this is multiplication that gets you 0 means one of your two numbers has to be 0. So I'm going to say that either the y plus 3 can equal 0 or the y minus 6 can equal 0. Okay, and then we're going to solve each one of these and you get y equals negative 3 or y can equal positive 6. Now, if this factoring thing was not connected to this picture over here, you would be done and you'd have two answers. However, it is connected to this picture over here, and since this picture over here involves side lengths, you need to make sure that when you plug in negative 3 and 6 to the 7y plus 18 and this y squared plus 4y, that you're not going to get a negative number, because you can't have negative side lengths. So I'm going to go over here under my picture, and I'm going to start with the y squared plus 4y. But instead of y, I'm going to put negative 3. So I'm going to have negative 3 squared plus 4, and then in parentheses I'm going to have negative 3 again. And we're going to figure out what that is. If that's a negative number, this negative 3 option doesn't work. So this is positive 9 plus, and then 4 times negative 3 is negative 12. Plus a negative is the same as a minus, and 9 minus 12 is negative 3. So that tells us automatically you cannot have negative side lengths of things. That tells us we need to throw out this y equals negative 3 option. That cannot work. Okay, so since you got a negative here, you don't really even have to test this other side. But if you wanted to, 7 times negative 3 would be negative 21 plus 18. That's a negative number. Okay, so we're throwing out that y equals negative 3 option. And just to be safe, let's double check the 6. I'm going to go over here this time. So I'm going to have, let's see, I'm going to have, instead of y squared, I'm going to do 6 squared plus 4, and then instead of y, I'm going to have 6. 36 plus 24 is 60. That's positive. And then since it was supposed to cut things in half, and from A to C is the same as from C to B, let's double check that when we plug it into 7y plus 18 that we get 60 also. So 7, instead of y, I'm going to put 6 plus 18. This is 42 plus 18, which is also 60. Okay? Those are the same. They're both positive. That's good. So in this case, this y equals 6 is our only option. Okay, so we only have one answer here because this negative 3 that we came up with gave us a negative side length, which we know can't happen. Okay, again, if you don't have a y squared, you're probably not going to factor. It's probably just going to be y, just solve for y like normal. It's when you have this squared term right here in the beginning that you have to think about factoring. But that's it.